Hello and welcome to our forum Tech Talk. Today we have with us Dr. Lavkesh Vig, Principal Scientist TCS. Dr. Lavkesh Vig heads the Deep Learning and Artificial Intelligence Research Area at TCS Research New Delhi, where he is currently serving as the Principal Scientist. He completed his PhD in Computer Science from Vanderbilt University, USA, and has since served at Bloomberg R&D New York and as a faculty at the School of Computational and Integrative Sciences, Jawaharlal Nehru University, before migrating to TCS Research. Thank you so much for joining us for today's session. To start with our first question, sir, I wanted to ask you that do you think that neural networks really are the answer to artificial intelligence?
Well, if you asked me that question 5 years ago, I would have said a very confident no. There have been developments over the past 2 years that have made me question that statement. But let me just trace back. So AI in general, getting general purpose AI to work requires both perception level intelligence, the ability to be able to detect objects in images, for example. And it also requires reasoning or high level deliberation over what you're perceiving. And while neural networks revolutionized and deep learning revolutionized in the early years the perception module, or what we in the research community call system one capabilities, the reasoning component was something that neural networks traditionally struggle with. There's also the additional issue of domain knowledge and how do you imbibe domain knowledge into these neural networks. So these were two very prickly issues for neural networks that I thought the solution to these would be to integrate neural networks with symbolic AI, which is the traditional good old-fashioned AI, which is logic and inductive logic programming and Bayesian modeling and so on. However, what has happened in the last 1 or 2 years is that these models, these large language models and these large generative models have started to exhibit some very prominent reasoning capabilities on their own. These capabilities only manifest at a certain scale. So about 40 to 50 billion parameter neural networks start to exhibit these properties. And so the entire field now is kind of turned on its head by the latest advances in deep learning. And people are calling into question whether the symbolic component is still required. My opinion is it will always still be required, although I'll admit I'm very surprised by these latest developments.